For this first course, we want to get our schema registry up and running, understand how Avro works for Kafka messages, and publish our first schema. To get our local setup in order, we'll use Docker and Docker Compose. You can get a Docker Compose file from the course's Git repository. As you can see, we have a broker, the schema registry itself, and control center, which I'll tell you about in a minute. Clone this on your machine and let's run Docker Compose up to start our services, and I'll give them a couple of minutes to get running. Until then, let's overview what we're spinning up here. First, a Kafka broker, nothing out of the ordinary here. Secondly, a schema registry instance. The registry will typically leverage Kafka to store the schemas and some other metadata. It also exposes a REST API that you can use to interact with it. When we'll be writing producers and consumers in Spring, those will under the hood use this REST interface to talk to the schema registry. We're also spinning up a control center instance. This is a web-based user interface that also talks to the registry through its API, and we'll be using it because it's convenient and should make everything simpler to visualize. After our services have started, we can head to Control Center at localhost 9021, and we can see we have one healthy cluster. Click on the cluster and let's create our first topic. Go to Topics, Create Topic, give it a name, I'll call it User Registrations. Now, by going to the Schema tab here, we can see that we can set a schema for both the message values and the message keys. If you remember, that's how Kafka messages work. They are composed of a message key, which is just a byte array, and a message value, which is also just a byte array. Now, let's try and create a schema for our message values. Click here on Set a Schema, and we are presented with this sample schema in Avro format. Let's first understand what Avro is and how it works in the context of Kafka-driven applications, and then we'll get back to creating and publishing our first schema. Avro is an open-source data serialization system maintained by the Apache Foundation. It defines how to create a schema for your data models and how to serialize and deserialize the data using schemas. Avro schemas are defined in AVSC files, which are text files that use JSON syntax. Using AVSC, you can define data using the usual primitive data types, such as booleans, int, long, float, and double for numbers, bytes for byte arrays, strings, and null. You also have access to complex data types like enums, which are a set of named values, arrays, which are lists of elements of the same type, maps, which have string keys and values of the same type, unions, which can conform to one of several types. For instance, you can use the union of null and string to define what is basically an optional string, and fixed, a fixed length byte array. Using all of this, you can define records, which are collections of named fields where each field can be of any data type. Data models in Avro have names, and they belong to namespaces, which are similar to those found in Java. They exist to avoid name collisions in larger systems. We can also use the doc field to provide documentation for our models. Here we have an Avro schema for a user-registered event data model. We want to use this schema for the message values for a topic called user registrations. Kafka messages are composed of keys and values. When using the registry, you can define schemas for both. The entity to which you associate the data schema is called a subject. Subjects typically follow the naming convention of topic name followed by a suffix, which is dash key or dash value. So when we want to use this schema for the message values of the topic user registrations, we can say that we want to register this schema for the subject user registrations value. Good, so we registered this schema for the user registrations value subject. When we register a schema, a few different operations are performed. The schema will go through a normalization process, with one of the most significant effects of this being that the schema fields will be ordered in a specific way. Then some metadata will be associated with this schema. It will receive an ID, which is an integer, and is unique in the context of the entire schema registry, so across all subjects. It will also receive a version which is scoped to the schema subject, in our case user registrations value. Assuming this is the first schema for the user registration message values, the newly registered schema will have version 1. If we were to upload another schema for this topic's message values, that new schema would get version 2, and so on. Now, when user registrations topic producers will want to send the user registered event message into the topic, they will first communicate with the schema registry, which will provide them with the schema and its ID, the one that was set when we published the schema in the registry. Next, the message will be serialized, and this is where Avro shines for Kafka-driven data exchanges. You see, one of the main advantages of using Avro is that the data will be serialized using a binary encoding, making it more compact than, say, its JSON text encoding counterpart. Here's how Avro serialization achieves this. The encoded payload begins with a single byte, known as the magic byte, with a value of 0. This is used to signal that the message is encoded with binary Avro. A deserializer that expects binary Avro can tell immediately if the payload that it receives is not encoded correctly, if the magic byte is missing. The next 4 bytes represent the schema's ID, the one that the schema registry sets. Using this ID, deserializers can identify exactly what schema was used to encode the payload, and they can retrieve that exact schema from the registry. Because schemas are normalized when registered, they maintain a specific order for the payload fields. This means that serializers and deserializers using the schema know exactly in what order the fields are, what are their names and their data types. Therefore, field names can be omitted entirely from the payloads, making Avro-encoded payloads smaller in size. Now that we understand the basics of how Avro is used by the schema registry to facilitate data exchanges in Kafka, let's head back to the control center and register our first schema. From the course's Git repo, I will copy this user-registered user event schema, which contains a username and a Boolean flag that indicates whether the user has a premium subscription. Let's use this schema for our user registrations topic message values. Paste it here and click on Create. As we can see, we now have published our first schema. It was given an ID and a version. Let's try to register another schema for this same subject. Go to Evolve and we'll update this schema with another field, which can be double or null, and we'll give it a default value of null. And we'll see why we had to provide the default in a future video. Now we can see this new schema was added on our subject. It has version 2 and a different ID. So now we know how to set up the schema registry on our local machine, what AVSE files are, and how Avro uses binary encoding to make the payloads compact and efficient, and we published our first schema. That's a very solid start. Thank you for watching, and we'll see each other in the next one.